Section 1.7, Linear Inequalities and Absolute Value Inequalities. So now we're going to be solving linear and absolute value inequalities. So to solve absolute value inequalities, again, if you see a less than symbol or a greater than symbol, you're going to use parentheses to show that you do not include that starting or ending point. If you have a less than or equal to, greater than or equal to, again, you'll use a bracket to show that you do include. Now here's where you got to be a little careful when you're solving absolute value inequalities. If you remember back to absolute value equations, we always had two answers. So we're going to have to break this up into two separate inequalities or keep them together as a double inequality. And I'll show you how that works. So we're going to say let U be an algebraic expression and C be a positive number. So if the absolute value of that algebraic expression is less than or less than or equal to that constant positive number, the numbers that satisfy is where you put U in between the two C's, with one being negative and one being positive. Now again, this could be less than or equal to or strictly less than as well. Now, if the solutions of the absolute value of U are greater than or equal to C, then those are the numbers that are going to satisfy where you have to break it up into two separate inequalities. U will be greater than or equal to C, or U will be less than or equal to negative C. You see how the inequality flipped? It actually flips here, but because U is in the middle, it doesn't look like it's flipped, but this is read as U is greater than or equal to negative C, but U is also less than or equal to positive C. So U is in between. So even though it doesn't look like the inequality is flipped, it does. So when you have a less than or equal to or less than symbol, you keep it as a double inequality. If you have a greater than or greater than equal to, that is when you need to separate it into two separate inequalities. So let's go ahead and try these problems. Solve each absolute value inequality and graph the solution on the number line and write in interval notation. So number one, we have strictly less than. Make sure you isolate the absolute value first, and then you look to see if it's a less than symbol or less than or equal to. So this, like the first example. So we take the absolute value off of 3x plus 5, and we're going to have to be less than 17, but then greater than negative 17. So the 17 changes sign to go on the left-hand side, and on the right side it stays positive. So kind of like when we broke it up into two separate equations when we had absolute value equations. So now we're just going to solve this as is, keeping the x in the middle. So we're going to subtract 5 in the middle, on the right, and on the left. So we're going to get negative 22 is less than 3x, which is less than 12. And then we're going to divide the middle by 3, the right and the left by 3 as well. So we'll see this is negative 7 1/3 is less than x, which is less than 4. So at this point, we don't have to do a test point because we already know that x is going to be greater than negative 7 1/3, but also less than 4. So here's 0 in the middle. We'll put 4 over to the right, negative 7 1/3 off to the left. So now looking at this, since x has to be in between those two numbers, we will shade in between. Since they are strictly less than symbols, we are going to use parentheses to show that we do not include those ending points. So for interval notation, we're going to go from left to right and show you what we shaded. So we started at negative 7 1/3 and we ended at 4. So negative 7 1/3, comma 4. All right, so looking at number 2, the absolute value of 3x minus 3 over 9 is greater than or equal to 1. Since the absolute value is isolated, we do know that we are going to use the step number 2 instead because of the inequality is greater than or equal to. So we're going to break it up into two separate inequalities. 3x minus 3 over 9 is greater than or equal to 1, or 3x minus 3 over 9 has to be less than or equal to negative 1. So that would be that piece right there, and that's this piece. So now how do we solve fractional inequalities? Well, we're going to multiply both sides by 9 to get rid of the fraction. So 3x minus 3 is greater than or equal to 9. We'll multiply both sides by 9 on this one as well. So we get 3x minus 3 is less than or equal to negative 9. And then we're just going to solve these equations. So we're going to add over the 3. So 3x is greater than or equal to 12. so x is greater than or equal to 4, or add over the 3, so 3x is less than or equal to negative 6, so x is less than or equal to negative 2. So here's our 0, 1, 2, 3, 4, negative 1, negative 2. Things that are less than negative 2 are to the left, so we need to shade off to the left. Negative 2 this direction with an arrow, again pointing that we continue to go that direction. X is greater than or equal to 4, so we're going to go to the right and shade that area. Because we have greater than or equal to and less than or equal to, we're going to use a bracket to show that we do include those starting and ending points. So definitely use a bracket to show that. And then we're going to do interval notation from left to right and show us what we shaded. So negative infinity to negative 2 bracket, union, bracket, 4 to infinity. All right, so on the next page, page 30, we have a couple more problems to try. We have a greater than or equal to, but as you can look at number 3, you'll see that it is definitely not isolated first. So be careful with this one. To isolate the absolute value, we need to divide by negative 3. When you divide by negative 3, what happens to the inequality? Well, the inequality would flip. So we get the absolute value of x plus 7 is now less than or equal to 9. So make sure you isolate first before you decide how you're going to break it up. Now that we're less than or equal to, we can keep it as a double inequality with less than or equal to 9 or greater than or equal to negative 9. So we keep this one the same, we change the sign. The inequality actually does flip, but because this is in the middle, it might not look like it. Then we're going to solve for x by keeping x in the middle, so we'll subtract the 7 from the left, the middle, and the right, and we get negative 16 is less than or equal to x, which is less than or equal to 2. So on the number line, here's 0. We'll just come out to the left and put a negative 16, and we'll put a 2. So now this says all the numbers that are in between negative 16 and 2. So we'll shade in between negative 16 and 2. Because of the less than or equal to symbols, we know we have the bracket to show that we do include those points. So our interval notation going from left to right goes from negative 16 to positive 2. So I'm going to circle number 4 for you to try, and then you can send me the answers and I'll let you know if they're correct.